All right. So what can I help you with tonight?
Let me just park really quickly.
That is fun. Oh, are you driving?
Yeah, but I'm not typing. That's why I want to park really quickly before
That's cool.
I
I'm gonna go get my beverage. I'll be right back while you park.
all right.
Who's a good boy? Oh, Rocky, you're such a good boy. Who's a good boy? Oh, you already had supper, Gracie. Thank God. Yeah, just I'm just shot at dinner. Did Rocky eat for dinner? Yeah. Still hungry? Well, I guess you're gonna eat a little faster tonight. Gotta eat a little faster. Yes. All right. All right. There you go. All right. Okay. Here you go. Oh, you're a hungry girl. There you go. Rocky, leave Grace's food alone. Come, come, come. Good boy. Oh, good boy. Lie down. You've had supper. Lie down. Mm-mm-mm. I've got a dog, and then my neighbor never feeds her cat, so I've got a cat too. Lie down, Rocky. Yes, lie down. You're a good boy. You're very dedicated to be here when you're in your car.
Yeah, because I just wanted to do it because I forgot about it.
Good for
But
you, man.
hold on. How do
That's
I
fine.
because it says your editor share notes with do I just share to meeting?
Do you want to share something with me? Do you want to show me something?
'Cause yeah, I was just asking for help on problem 6 with special homework 2.
Okay, hang on.
Okay.
You can share your notes, or we can look at problem six together. What would you prefer?
We could look at it together.
All right, I'm going to share my screen, and then I'm going to go to my special homework number two, is it?
Yeah, because I didn't answer it on
That's
mine.
cool. Oh, good for
That
you. You're asking now. That's
yeah, because
awesome.
I was so late and I couldn't even.
Don't, hey, listen, I get it. I'm trying to make this thing go kind of out of my way. Let's see if I can resize this thing, make it like that. Okay. All right, special homework number two. Let's make it a little bigger. And we're looking at problem number six. Oh, yeah. Oh, that's a fun problem because you have to do something constructive.
Hmm.
All right. So we've got a universal set. It's just the numbers one through nine. You understand that.
Yeah.
Now your job is to construct subsets A, B, and C of that set U. That means, when you build A, the elements from A have to live in U. When you build B, the elements of B have to live in set U. Same with set C when you build it. So you're going to build one collection of sets. You're going to call them A, B, and C, and they have to satisfy the three properties listed. Read the three properties. Can you see it? Should I make it bigger?
The three properties.
Yeah, let me make it bigger. There we go. So can you see property A?
Is a subset of B.
Yeah, set A is a proper subset of B. Do you remember what a proper subset is?
Uh,
Let me remind you. First of all, a proper subset is a subset. Okay, so let's review what it means for A to be a subset of B. It means every element in A is also an element in set B.
Okay.
A proper subset, well, A is a proper subset of B means A is a subset of B, but B is not a subset of A. It means B has at least one element that is not in A. So in some sense, it's like the strict less than. A has to be somehow strictly less than B. It's going to be a subset of B, but it can't be as big as B.
Right.
B has to have more. Okay?
Right.
So, all right. What's the second property?
B and C have no elements in common.
Okay, so that means B and C can't share any elements. And
Right.
what's the last property?
A times C has exactly 12 elements.
Fantastic. All right, so I'm going to write this stuff down on the notes. Oh, it's problem number 6, not problem number 2. It's homework 6. All right, so the universe has 1, 2, 3, 4, 5, 6, 7, 8, and 9 in it. And we're going to construct sets A, B, and C, subsets of U
Mm.
that satisfy A is a proper subset of B, B and C share no common elements. There's a word for that. When two sets share no elements in common, we say they are disjoint from one another. We haven't learned that yet, but that's what the definition is. And then finally, A cross C has exactly 12 elements. We might want to think about that last property first. A cross C has exactly 12 elements. Do you remember how we build a cross product set? Shall we review that?
Yeah.
Let's review that. Okay, here's an example of a cross product set. Let's say Y is the set that has little x, little y, little z, and little w. And let's say big W is the set that has little y and little z in it. Find set big Y cross set big W. We say that's the Cartesian product, Y cross W. All right?
Right.
So the elements look like ordered pairs. Y cross W, by definition, is going to be the set of elements that look like this. Little a comma little b in parentheses, where little a is an element of set Y and little b is an element of set W. So the elements are ordered pairs. So when we want to build a cross product, A cross C, that has 12 elements, that means we want 12 ordered pairs. It means we have to pick a Y, well, here it's going to be an A, set A, that has some number of elements, and W, that's going to be our C, has some number of elements, so that the number of elements in Y times the number of elements in W is 12. In other words, the number of elements in A times the number of elements in C, the number of ordered pairs, is 12. So here, Y has four elements, W has two elements. For this Y and this W, how big is Y cross W going to be? Let's think about it.
I
When we
mean, if it's like
go
um
ahead, you tell me if you know.
y times w, so it'll be y squared, z
It's
squared.
the
No.
size of Y. We have four choices for the first coordinate,
Yeah.
and we have two choices for the second coordinate. So if we mix and match four choices for the first coordinate times two choices for the second coordinate, we
The
get,
eight choices.
yes,
Yeah.
exactly.
Hmm.
So we're going to have eight ordered pairs in Y cross W because Y has four elements and W has two elements. For example, if we were going to do this sort of in alphabetical order, our first ordered pair might be little x for a first coordinate, comma, and then we pick little y for a second coordinate. That's one of the elements in Y cross W. What's another element in Y cross W?
Um, it'll be x and z.
Yep, x comma z, and we put them in parentheses. That is a single element
Right.
because the elements are ordered pairs. Good. Let's keep going. Let's do this.
So y and y,
Y comma y. Good.
y comma z,
Perfect. Keep going.
z comma y,
Yep.
z comma z,
Yep.
w comma y, and
Yes.
w comma z.
Perfect. So this Cartesian product had eight elements because we had four times two.
All right.
Now, when we build A and C, we want A cross C to have 12 elements. So there's several different ways we might do that. Like, can you think of a size of A and a size of C that would work to make A cross C have 12 elements? We want A cross C to have 12 elements. I can think of several different ways that we can get to 12 by multiplying different numbers. Can you think of some different ways to get to 12 by multiplying two numbers?
So hmm. So if it's a times c, that means like a would equal 3,
Yep,
and then
size of A could be 3.
C could be size 4.
Exactly, because 3 times 4 equals 12. So that's one way to do it. Can you think of another way to do it?
Um, size size A will be 6, size C will be
Yes.
6. No, no,
Six,
2. Sorry.
2.
Yeah.
Good. Right. And of course, 12 times 1 would work,
Mm-hmm.
but that's not going to work out for us
This
because
is not a.
yeah, we don't have enough elements to make A have size 12 because A has to be a subset of U, and U's only got 9 elements. But we
Mm,
could make A have 3 elements and C have 4. We could even make A have 6 elements and C have 2 elements. Either
right.
one of those will work out. Or, A could have 4 elements and C could have 3, and A could have 2 elements and C could have 6. But at least we've got that in the back of our mind, right?
Yep.
Then we have to make sure that whatever A we build and whatever B we construct, A is a proper subset of B. That means A's elements have to be in set B, but B's got to have something else that A doesn't have. So here's a good time to choose how big we want to make A.
Um, I, 3 is fine.
Okay,
Yeah.
so tell me, let's let A have 3 elements. Okay, let's try that.
And I'm thinking X, Y, Z.
It would be X, Y, and Z if those were options, but look at our universe.
Oh,
So we
one,
got to
two.
pick from these.
one, two, three.
Sure. Let's pick one, two, and three. Perfect. Now, we need to build a set B that it contains all these elements of A and at least one extra one. So what would you like B to have in it?
One, two, three, four.
Perfect. So we have already satisfied property little a.
That's what I'm saying. That's the part that I got, but I was confused on what I was
B,
doing at
B and
first.
C, right. Well, maybe this cross product kind of screwed you up. Like
Yeah,
how big is C gonna have to be if we've chosen A to have three elements?
before.
Yeah, C is gonna have to have four elements. So we know that. And when we build C, it cannot share any elements with set B. Well, that's
That
okay.
that was
We have
perfect.
lots of elements left. What could we
Be
make?
five, six, seven, eight.
Yes, five, six, seven, and eight. That'll work. And then we can verify each property, verify each property. To get full credit, you're going to verify. So property A, you're just going to say, hey, the set containing 1, 2, and 3 is a proper subset of the set containing 1, 2, 3, and 4. Why? Because it's a subset,
Hmm.
but it doesn't have everything. So A continued. Because, oops, A is a subset of B, but B has 4 in it while A does not. So we have verified A is a proper subset of B.
All right.
This is our A, this is our B. Then we have to verify that B and C share no elements in common. Well, we can just look at it, you
Hmm.
know, clearly, sometimes we can just say clearly B and C share no elements. They have no elements in common. And that's all you need to say. And then finally, we want to verify that our A cross our C has the right size. Well, A cross C has 3 times 4 equals 12 ordered pairs. And that's all you have to say.
Wow. Thank you. Thank you for explaining it to me.
You're so welcome. So would you like me to give you a do later?
Sure.
All right.
This is on the recording, right? So,
We are recording.
where can I access this after? Because
There
I don't
are
have a
two
pen.
there are two places. Let me show you.
Okay.
It takes a few minutes after office hours are done. But if you go to content, all right, so let me go to student view because I see things you don't. You don't need to see all what I see.
Hmm.
All right, so there's our Blackboard website. Do you see this videos of office hours?
Oh, okay.
All right,
Yeah.
that's one place. Here's our office hour from Monday, and here's our office hour from last week. Okay, there are only two so far.
Okay.
But there's another place. If you go to our syllabus, in fact, there's two places to go. If you go to our reading page, it tells you my YouTube channel right there.
Hmm.
It's also in the syllabus. Maybe I'll just put a link to my YouTube channel. But anyway, if you go to my YouTube channel, I'll just go to my YouTube channel and we look at the playlists. Now, I see a lot of playlists you can't see, okay? But you will see Spring 2026 Math 263 office hour videos. And there they are.
Okay.
Okay.
Thank
So
you.
So if you want the closed captions, then uh you should use the link that's in our Blackboard website. If you want the closed captions, if you go to the Zoom link, I mean, if you go to the videos of office hours, these should have the closed captions. They'll have everything. See?
Right.
Okay, does that help?
It does, yes.
Good. And all this information. Am I sharing my screen?
Yeah.
I wonder why it's asking me to share again. Oh, stop share. Okay. So all of that good information is in our syllabus.
All right. Thank you.
Uh-huh. And just sort of a word to the wise, no matter what class you're taking, your professor has probably set up some kind of a a Blackboard website, for your course. You should kind of poke around and follow every link in your Blackboard for the course because every link is going to show you some materials and stuff.
Mhm. Okay. Thank you.
Anything else you want to work on? Have you looked at special homework 3 yet?
No, yeah, I haven't had a chance because of class, but I just wanted to apologize for the special homework being a little messy.
All right, thanks.
Yeah.
Listen, special homework is not something. I'm going to unpin this for a minute. Special homework is not something that you can do an hour before class.
Uh,
Special homework is something you should start working on now, even though it's due Tuesday. You should start working on it and working the problems. And then on Monday, you should rewrite everything nice and neat and get it stapled and ready to turn in when you walk into class. It is not a last minute effort. It is a process. Every week, you're going to be producing something that's a reflection of your own effort, and it's worth producing something that's neat and that you feel confident about and that you've taken the time to think about. Now, sometimes you've worked on the problems over the weekend, they're due on Tuesday, and there's a problem, or two that you didn't understand. Well, that's why we have Monday office hours. So you can, get questions answered and get those solutions written up and then add those into your special homework, that you've already started. Like I said, special homework is not something you start an hour before class. Okay.
okay. Yep. Thank you.
You're welcome.
Did you ch check my special homework yet or not yet?
I have been incredibly, ridiculously busy since
No,
yesterday's class, but
makes
I will have it graded by Tuesday. I need a week to grade special homework. I've got 50 students, and
hmm.
I don't know, did you turn in special homework number one?
I did, yes.
Right. So I really, I read them and I comment, and it's about a 12 to 15 hour project. I spend every weekend grading special homework, and you'll get that feedback back Tuesday. If you are dying to get that feedback a little earlier, just send me an email and I'll take a PDF as soon as I grade your homework. I'll put it on the top of the stack and I'll email you a PDF of your graded special homework if you can't wait.
All right, so what time would that be best? Because I don't want to like, rush or anything.
Anytime.
Anytime.
If you send me the email, I'm going to put your homework on the top of the stack. If you care that much and you really want to see the feedback, I'll put yours on the top of the stack and I'll grade it in the first hour or two of grading.
Okay. I'll email you maybe on Friday.
That's fine.
Thank you.
Yeah, I wish I could turn around special homework, in 2 days, but that's not realistic. There'll come a
Yeah.
point where we're going to have a test and special homework will shift and it might be due on Thursdays instead of Tuesdays, and then you'll get it back on a Tuesday. But I need a weekend. Whatever day you turn it in, I need a weekend because it really, I guarantee you, I spend more time on this class than you do. I promise you that.
No, I
And
understand. Yeah.
And you can always email and request another office hour. If you start working on special homework and you're just burning up with questions, we can have a Saturday afternoon office hour or Sunday afternoon office hour. Just email me and ask what's the worst thing that could happen,
Okay. Thank you
right? I
for
mean,
giving
right?
me the opportunity. Thank you.
You're so welcome.
All right.
All right. Take care. Are you going to leave? Or are you going to stay?
Yeah.
All
Just
right.
because I have to go home now.
I understand. I'm going to put this on pause and wait for somebody else to come into the room.
All right. Have a good night.
You too. You'll see this recording in those two places that I showed you.
Okay. Thank you.
You have a great night.
You too.
Good night. Oops. Pause it again. Record it. So, what can I do for you? Do you have some questions?
Yes, I've been having a hard time with the converse and inverse.
Mm, the converse and inverse. Shall we look at some examples?
Yes, and also the negatives. The contrapositive, I think I'm good, but I would like to still have examples for that, so for all of them, I guess.
Okay, and negations. Okay,
Yes.
and the contrapositive. So we'll look at all of them. Shall we look at the rules first and then we'll look at some examples?
Mm-hmm.
Great. Okay, so let's just recall if P implies Q is the what we call the original, right? The original implication. Then we have three sisters. We have Q implies P, not Q implies not P, and we have not P implies not Q. Notice one thing that happens here. Either both of the components stay unnegated, or both of the components get negated when we build these sisters, okay?
Mm-hmm.
So Q implies P is the converse. Do you remember what we call not Q implies not P?
Contrapositive.
Yep, that you said you understood the contrapositive, so it is the contrapositive. And not P implies not Q is what? The
The
only
negation.
one left.
The inverse.
Good. Also, the negation of P implies Q is P, the hypothesis is true, and the conclusion didn't follow. So we say, and not Q is what happened. So those are the rules for the converse, the contrapositive, the inverse, and the negation. This is the negation. Okay. So we can look at an example or two.
Mm-hmm.
Have you been in class yet?
Sorry?
Have you had a chance to make it to class yet?
Yes, I was there this week.
Oh, I'm glad because I know you were having some issues with housing. I'm so glad that you made it to class.
Yes, it's finally been resolved. I've moved in, so everything's great now.
Fantastic. All right, so consider this implication. I'm just going to make up an example of an if-then statement, okay? I'll keep it simple for now, and then in the next example, we can make it compound, okay? If the sun is high, then the day is warm. It's silly, but we're just trying to keep it simple. So, one of the first things that you can do is just parse it out. What does that mean? That means the sun is high. We can think about that as being our P. And the day is warm. We can think about that as being our Q. And we're talking about if P, then Q. Does that make sense?
Mm-hmm.
So let's say we were asked to write the converse. B, contrapositive. And we might be asked these in a different order, C, inverse. And D, negation. Okay? So we can make a key. P is the statement, the sun is high. And Q is the statement, the day is warm. And that kind of helps us. And it can help us when things are more complicated as well. Okay? So let's go ahead and let's write the converse.
If the day is warm, then the sun is high.
Exactly. If the day, let me just speak this up. In fact, sorry, I'm trying to fit everything. I'm trying to trying to make a spot for my iPad. I need a bigger table and a spot for my pens and pencils and a spot for my cup. I'll move that. Okay. So and let me make this straight. Let me make it straight.
Then the sun is high.
If the day is warm, then the sun is high. Good. All right. How about the contrapositive? Do you want to look at the notes?
Yeah.
Contrapositive is not.
If the day is not warm, then the sun is not hot.
That's right. B. If the day is not warm, then the sun is not high. Perfect. And notice the contrapositive means the same thing as the original. The original is if the sun is high, then the day is warm. Well, that means if the day isn't warm, then the sun isn't high, because if the sun is high, the day is warm.
Mm-hmm.
How about the inverse?
If the sun is not high, then the day is not warm.
Yes. Sun is not high. And the day is not warm. What does this, what statement is the inverse logically equivalent to?
B.
Let's see. Well, B is the contrapositive, and the contrapositive is logically equivalent to the original, because remember, to get to the contrapositive, we switch the position of the components and we negate them both. But to get from the converse to the inverse, look what we did. we switched the two components and we negated them both. So the inverse and the converse are actually logically equivalent because they're contrapositions of one another. Okay. Now the negation. And here's the rule for the negation. The negation of P implies Q is P and not Q. So let's write the negation.
If the sun is high and the day is not warm.
Okay, let me ask you a question. You've made a very common misstep that novice, that students make, okay? This is very common, so don't feel bad about it. But notice the negation of an if-then statement isn't an if-then statement at all. It's an and statement. There is no if-then in the negation. Because remember what P implies Q means. P implies Q means if P is true, then Q must also be true. If that's not what happened, what really happened is that P is true and Q failed to follow. So the negation is an and statement. It's not an if-then. You want to try again?
The sun is high and the day is not warm.
Perfect. Very good. The sun is high. And you know what? If you want, you could say the word but, because but means and in mathematics. But the day is not warm. So the hypothesis happened, the sun is high, but, and the conclusion didn't follow. That's what it means to say the implication fails. It means P happened and Q didn't follow. Q wasn't true the way it's supposed to be if the implication is actually true. Does that make sense?
Yes.
Fantastic. So now shall we make it a bit more complicated and play the game with a compound statement?
Okay.
All right. So what do I mean? Well, here this was fairly simple because the hypothesis P is just a simple statement. It doesn't have an and or an or in it. And the conclusion is a simple statement. The day is warm. It isn't a compound statement with an and or an or. Okay? But either one of these might be compound statements. For example, consider this implication or this conditional. We use both words. An implication means the same thing as a conditional. If-then statements could be called implications, but they can also be called conditionals. All right? If-then statements have several names. I don't know why. I didn't make that up. It's just the way it is. All right. What about this? If Juan takes math 263, then Juan studies hard and Juan, let's see, what else would Juan do? Studies hard and Juan earns an A. All right, for example. Here we have what's called a compound Q. Our Q is actually an and statement. Our P is not compound. It's just a simple P. Okay? So P is just Juan takes math 263. Sorry, it's not very original. Q is an and statement. Juan studies hard and Juan earns an A. Okay, so when we start to go through same instructions, we're gonna write converse, B, contrapositive, same as before. C, inverse, D, negation. We're going to have to use De Morgan's laws when negating components or the entire statement. Oh, when negating components, and use the correct negation of the conditional, which is the same thing as the implication. You know, a conditional is an implication. So let's go through this. We have our P. All right. So do you remember what the converse of if P then Q is? We can look at our little list here. The converse is if Q then P. So it's sort of the easy one. We don't have to negate anything. Okay? We don't negate anything. So let's write A.
If one studies hard and one earns an A, then one takes Math 263.
Yeah. Like I said, it's not a great example, but it's okay. It gets the point across as far as compound components. All right. So there's the converse. Now we're going to find the what was next? Yeah, the contrapositive. Now the contrapositive is interesting because we are going to switch the P and the Q, right? The way we did here, but we're going to negate them both. So we could do it in steps, right? Okay.
If
If
one does not study hard
good.
and does not earn an A, then
All right.
one does
Well,
not
hang
take
on.
Math
You're
263.
very close. Yeah.
Or
The and changes to an or Juan does not earn an A. Then
one does not take Math 263.
exactly, Juan does not take Math 263. Very good. So you got the idea. You just used a Morgan's law to negate Juan studies hard and Juan earns an A. You negated it correctly. Juan does not study hard or Juan does not earn an A. And then, of course, the inverse is a lot like the contrapositive because we're going to still use a not Q and a not P, but we just put them in a different order, right? It's the not P implies not Q. So not P is pretty easy. So what is our
If
inverse?
if one does not take Math 263,
Mm-hmm.
then one does not study hard or one does not earn an A.
Perfect. And finally, for the negation, let's just review what the negation looks like. The negation of if P then Q is P happened and not Q happened. So Q failed. So we want to keep P and we want to negate Q.
One takes math 263
Uh-huh.
and one does not study hard and one does not study hard. Or one does not earn an A.
Great. Now something is going on here that we haven't seen this evening, but we saw it in class. We have an and we have an or in the same sentence. When we have an and an or, we have to use parentheses if it's in English. Commas, excuse me. We have to use commas if it's in English, informal. We would have to use parentheses if it was informal. No, if it was formal, like informal notation. Anyway, it's in English and we need commas. And the point is this. This and is separating the P from the not Q, right? So the commas go here and here because it's P and this compound Q, which you could call R or S, right? Or you could call it not R or not S. If R is one studies hard and S is one earns an A. See what I mean? So sometimes parsing things out can help us. So when we have this and, it's the last operator that operates. The not happened, the or happens first. The nots actually happen very first, but then the or. Since the and is happening last, we put commas around it. And that groups the or with these two together. And then the and happens last to and it together with the P. Does that make sense?
Yes.
Good. That was a good question. I have to think up something on the fly, and I wasn't feeling very creative, but I guess it did the job. There are lots of ways to get compound, components. We could do one more example that might sort of be helpful because I don't want you to think that there is never a not in one of the components. What about this? If the object is a moon, then the object is not a sun. Or let's say a star, then the object is not a star. If the object is a moon, then the object is not a star. That makes more sense. Okay? So again, the object is a moon, could be P. The object is not a star, is our Q. So there's a not kind of built into our Q. Now you can write that as Q or you could write it as not Q. But the point is, when we try to find the converse, the contrapositive, and the inverse, we have to deal with the fact that Q is a compound statement. It happens to be a negation. So when we negate it, right, it changes this not a star to is a star. Does that make sense? So P could be the object is a moon. And I think I have to get rid of that pen because I think it is running out. And Q can be the object is not a star. So just for a little variety, it's helpful now to go through our exercises and let's find, again, A, find each. A, the converse. B, the contrapositive. C, the inverse. And D, of course, the negation. Okay, so let's practice one more time using this P and this Q. And again, one more time, we can look at our rules just to review. If P implies Q is our original, Q implies P is what we call the converse. You know the contrapositive, not Q implies not P. The inverse is not P implies not Q. And the negation is P and not Q. So there's actually a fact involved when we negate the object is not a star. The negation of that is the object is a star. It's kind of like not who's there? A star. All right, here we go. What is the converse?
If the object is a star.
Ooh, we got to keep it just the way it is. We're
Oh,
not going to
if the object is not a star,
good.
then the object is a moon.
Perfect. And we could even just say it is a moon. It's okay to not say the object again if we're tired,
Mhm.
All right. Now the contrapositive. Not Q implies not P.
If the object is a star,
Exactly.
then it is not a moon.
Perfect. Good. And now the inverse.
If the object is not a moon, then the
Uh-huh.
object is a star.
Perfect. And finally, the negation.
It,
Yeah.
the object is a moon,
Uh-huh.
and the object is a star.
Good. The object is a moon and the object is a star, which of course, is silly because it's the negation. It's false. The original is true. And the negation is going to be silly. It's going to be a false. Good job.
Thank you.
You're very welcome. Can I help you with anything else?
That was all. Thank you so much.
Hey, and listen, Malayla, if you need an extra Zoom office hour over the weekend as we start into special homework 3, please email me and ask, okay?
Okay.
All right. Take care.
Thank you.
You're welcome. Well, folks, we've just burned a perfectly good hour and 10 minutes of your time. If you're watching this, maybe you've listened to it in 1.5 time. Maybe you are listening to it in regular time. I hope it helped. And please email me if you need an extra office hour this weekend. Special homework 3. It's special. I'm looking forward to playing with you. Good night.